log base 2 of x. So what we're going to do is we're going to do 1, 2, 4, and 8. Those are powers of 2. So that's 0, 1, 2, 3. The domain for logarithms starts at 0, infinity and goes range negative infinity to infinity. You are supposed to remember that a logarithm looks like this with a vertical asymptote on the y-axis. If you don't have that solidified in your brain, what are you going to do to get it solidified in your brain? Like, that's now on you. We've covered this this is our third time to tackle the graph of a logarithm. So what will you do to help yourself? All right, the transformations. I see 3. What are the transformations? Yeah, Matthew.
Down 3, left 1, and a reflection across that y-axis.
Isn't it over the x-axis? Yeah, there you go. Nice job. Nice job. So we're going down 3, left 1, reflection over the x-axis, and we should be in awesome shape with our transformations. My mapping notation. Anybody want to try it? What would be the mapping notation based on these 3 transformations? Yeah, Brendan?
Parentheses, negative x minus 1, comma, y minus 3.
Almost. The reflection over the x-axis means you replace y with negative y. So then, let's go ahead and take our x values and subtract 1. We're going to take the opposite of the y and down 3. My domain, I moved it left 1. So that's now negative 1 to infinity. Whoops, I forgot the vertical asymptote up here was x equals 0 to the parent function. So now it's x equals negative 1. Now notice my scale. My scale is going by 2s. So don't let that bother you. So I want to go left 1. I have 0, negative 3, 1, negative 4, 3, negative 5, 7, negative 6. So do you notice it has been reflected over the x-axis? Now it doesn't stop there. It does continue up. And then now we got to find the x-intercept. Isn't the x-intercept where the y is 0? So let's go figure that out. So I'm going to add 3 to both sides. And then we need to divide by the negative 1. This is going to be a yucky fraction. But that's okay. We can figure it out. All right, so I'm going to divide by the negative 1. And then all you do is go to exponential form. That's 1/8. Oh, that wasn't too bad. If I subtract 1, that's negative 7/8. Make sure on the graph that you don't stop it here. A logarithm, remember, whoops, and I forgot, let me go back up here. the range is always negative infinity to infinity for a logarithm. And that should make sense because an exponential function has domain negative infinity to infinity. So the range of a logarithm should be negative infinity to infinity. All right, so number 2. Let me have you write something down. To find domain of a logarithm, set inside greater than 0. To find vertical asymptote of a logarithm, set inside equal to 0. This is kind of the fastest way to do it. Again, to find the domain of a logarithm, set the inside of the logarithm greater than 0. To find the vertical asymptote of a logarithm, set the inside equal to 0. So what I want you to do is I want you to go to number 2 here and do those to find the domain and vertical asymptotes of each, A, B, and C.
This is set inside greater than 0. What do you do?
So what's the inside of that log?
That.
X minus 3, right?
Mm-hmm.
So set x minus 3 and use the greater than symbol. Then you solve. So here's what I mean in case you're having some difficulty getting started. So to do my domain, you set the inside greater than 0. So x is greater than 3 means 3 to infinity. That's my domain. The vertical asymptote, you set the inside equal to 0, and that's x equals 3. Now do that with B and C if you were struggling to get started. All right, let me do this next one. I'm going to set 4 minus x greater than 0. You subtract the 4, but do you remember when you divide by a negative? So my domain is negative infinity to 4. The vertical asymptote, you set 4 minus x equals 0, so x is 4. My domain, I set x plus 2 greater than 0, x is greater than negative 2. And then the vertical asymptote is x equals negative 2.